So today's video, I initially wasn't actually going to release it. I actually lost quite a lot of footage from the video due to recording glitches. But having researched the fix that I attempted in the video, I really didn't find anything at all anywhere which showed a repair of the Thurlby 1905A, keeping the original keypad and without making huge major modifications. I saw one video on YouTube where a guy just described the fix by drilling lots of individual holes in the aluminium backing plate and mounted switches on the back. I saw another YouTube video on the same piece of equipment where a guy actually made an external keypad for the unit, which, although was a solution, didn't appear to be a particularly great one. It is quite a niche piece of equipment, it's very old, but I have addressed a very common issue with the device. No spare parts have been available for several years as far as I'm aware. So the video was actually shot some months ago, and as I say, I wasn't going to release it, but I have decided to do so. So it's basically split into two areas. The original problem with the device was it actually stopped working, as you'll see in the video, and the steps to actually fix that are quite well detailed. While I was inside the unit, I thought I'd have a go at fixing the keypad, and the steps that I went through to do that are kind of shown, but as I say, I did lose some footage, but let's have a look at it anyway. So here it is for what it's worth. So the faulty piece of equipment in question is this guy here. If I can find the on-off switch. As we can see, in the ohms range it seems to be working okay, but then when we go to the voltage range, we get a static voltage of like 5 volts. And it's slowly creeping up as well. So let's get this guy on the bench and open it up and see if we can fix it. So we'll start by flipping it over. And we'll take out the 4 screws from the bottom. This isn't the first time I've had this apart, or the second, I think probably the 3rd or 4th. In the past, I've had problems with the voltage reference. It's got a precision voltage reference in here. I can't actually remember what the part number is, but we can look at that in a moment. I think I've also seemed to remember replacing a voltage regulator in here also. So there's 4 long screws. And I think now, we can take the lid off. Well, he says, there we go. As I said in the past, I've had trouble with the buttons on the front panel here. There's a ribbon cable, or there was a ribbon cable that connected from the front panel onto this connector here. That ribbon cable broke off a long time ago, and I've actually removed this panel in the past. As you can see, I didn't bother sticking it back on because I thought at some point in the future I'll probably come back to it and try and have a go at fixing it, which I may well do. in a short period, and later in this video possibly, or in a subsequent video. But for now I just want to try and get this thing working. So a quick overview from what I remember. It's got a 6502 CPU. It's got a 6522, I think that's some kind of peripheral attachment that's married up to a 6502 CPU. It's got a single EEPROM. Now I think this is a 64K EEPROM. There are two sockets here, which I believe you had the option for two 32K EEPROMs, which are probably selected with these jumper wires here to determine whether you've got the 164K or the two 32Ks. This static RAM chip here, I think it's a 16K maybe, and then we've got a few logic chips. I think I'm not sure exactly what they are, to be honest. We've got a whole row of transistors here which drive the LED 7-segment display, and then we've got the header for the front panel. There's a DIL socket plug here that goes to the lower analog board, which is where the power supply and all of the analog circuitry hang out. So the first thing I actually want to test is the power supply. That's my main suspect with this kind of problem, because the ohms range seems to be working reasonably well. I believe that the issue is going to be with the power supply. So I'm going to go ahead and remove the digital board here so we can get to the analog board and get to the power supply for some testing. So I'll go ahead and I'll do that. So to start with, I'm actually just going to remove the stand section here, which I believe just comes off by itself individually. Yes, it does. It's a bit of a tight squeeze. There we go. Okay, that's better. Right, I'm going to start by removing these 4 nuts here, and I believe I have a 5.5mm. Whether this is originally 5.5mm, I doubt it, because I think this was probably designed in the inch scale. So we'll remove these 4 nuts, and there are some fibre washers underneath those guys as well. Going to leave that board connected for now, and I think at this point I will remove this shield here also. So there are, you see, I've had this apart before because I've actually marked where the screws go. There's 1, 2, 3, 4, there's 5 metal screws, and there are 2 nylon screws. So that's 1, 2. Two of those. Okay, should be able to take this panel out now. Okay, so we can see the analog board in here. I'll just switch to a slightly higher magnification camera so we can actually see inside this guy a little bit better. So there's lots of adjustment pots here. They are for calibrating. Somewhere I have a service manual for this that has a calibration procedure. the area we're going to be focusing in to start with is right down here. So down in the depths here, there's a couple of voltage regulators. I think they're 15 volts, a 7805 and a 7815 and a 7915. I believe there's also a 5 volt regulator which is adjusted with this pot here. So I'm going to switch back to the other camera so I can measure the voltages and get the meter in the shot. So I think we'll start. I should be able to hold the ground probe on the ground here, and I don't know if you guys can see, but this is one of the voltage regulators. So the voltage coming in, we have, this must be the 9 volt regulator, so the input is on pin 2. We've got 24 volts coming in, and we've got 2.5 volts coming out, and then the other regulator I believe is this one, which will be the positive 15 volts. Yep, we've got 24 coming in, and 9 coming out. And I believe the 5 volts is here, which is, oh, that's high also, 6.3. We've definitely got a problem with the 15 volt regulators, and in addition to that the 5 volts is also seems to be a bit high as well. So let's get the thermal camera out and see if that's going to tell us anything. So we can see there that there's a device that's getting very, very, very warm. It's up to 77, 78, 80, 79 degrees. You probably can't see that very well. Now that device is in fact this guy right here, which is a precision voltage regulator. Now I know this because I've actually had to change that in the past, and that actually has a heater inside. So that, I think, and it's remaining quite steady at 80 degrees. Let me just check that again. Find it. Yeah, it's actually down in temperature again now. So I'm pretty sure that that's fine. So back to the wider shot then. Now these are the voltage regulators down here. Oh yeah, I can immediately see, I don't know again if you guys can actually see that, the voltage regulator, that's now up to 145 degrees, and that one is at, come on camera, 132. Okay. So I'm just going to have another scan around the board here for anything else that might be getting hot. That is the voltage regulator, or it's a precision voltage source actually. Ah, okay, we've got something that's at 50 degrees. Let's put the lens on this. Alright, let's just get that in shot for you guys. Okay, let's power back on. Yeah, we've got immediate heating up down there. Okay, so is that? Ah, okay. I see the problem. It's probably hidden from your view. Okay, so we've got, unsurprisingly, we seem to have some tantalum capacitors here, one of which has actually changed colour. Now I'm looking at it, I can see that this guy started to change colour, it's starting to go brown. This one here was also getting very hot. So unsurprisingly, for a 30-year-old piece of equipment, we've got some tantalum capacitors that are starting to fail. So let's see if I can get those into shot for you guys to see. There. So we've got two tantalum capacitors right here. One of them is very brown. Actually, there's another two here also. So I think what we're going to have to do is change those guys out, and we'll see if we can change all four of them. So I'm going to go ahead and start taking the rest of the unit apart so we can actually get to the tantalum caps. So I'm going to totally remove the digital board here, so I want it right out of the way. So we'll disconnect that, and we'll remove the two soldering lines off. Wait a moment please. Soldering line's warm now. Out of the way. Okay, let's flip. Let's take the bottom cover off. Hey. And okay, there's a shield. Yes, I remember. So let's locate those tantalums. They are there. We'll pop those out. Get those with some pliers, I'm afraid. I can't grip. That's one. Oh, sorry you guys didn't see that. Try and do this one in shot. Two. Now I don't actually have tantalum capacitors, don't really like them to be honest, so I'm going to find out what the values are and replace them with ceramic, multi-layer ceramic capacitors. So let's see if we can find the circuit diagram and identify them. So here we have the service manual. I see it says Sinclair on there, which isn't really accurate. I think Thurlby became Thurlby. It was purchased from a Sinclair, oh I can't remember the name of it now. Sir Clive Sinclair had an instrumentation business which he sold, I believe, in the early 1970s or somewhere around there, and it was named Thurlby. I don't think this particular instrument has anything to do with Sinclair whatsoever. Anyway, let's find the layout first. Here it is. So the two tantalums are this one. These two are C30 and C31 maybe. Component list. C30. Okay, so the 10 microfarad, 16 volts. And the other tantalums are, just looking at the device itself here for a moment. There, so they're close by. Let's have a look. Back to here. We've got ports, it's these two, 27 and 24 maybe. 27, oh 26, so we've got another 10 volt 10 mic, the 16 volt, and the other one is 47 mic at 6.3. Okay, so we've got two 10 microfarad 16 volts, one 10 microfarad 10 volt, and one 47 microfarad 6.3 volt. I'm going to go and see what I have in the way of multi-layer ceramic capacitors that will fulfill those requirements. I found some multi-layer ceramic capacitors that will do the job. I think I will just mount them on the bottom of the board. So to do that, we'll put some blobs of solder on the pads. Take the first one. Okay. And the second one. Okay. Let's do the other two. So the first one is that one. Let's take these out. So that one is 16 volts, 10 microfarad. And I have here last one is going that way. That's that one. And that one is, just check, 47 microfarad 6.3. Put some solder on those pads. Cap. Okay, that should work. So I'm just going to make sure that I haven't actually got any shorts where I don't want them. So between there and there is good. Between there and there is good. There and there is good. Okay, that's good. There to there. That's okay. Yeah, that's good. Yeah, that's good. Okay. So let's just go ahead and test the power. So it's not so good. Then we have negative 14.9 and 14.8, that's good. I think we can go ahead and adjust the 5-volt regulator as well. Try and do that. Okay, 4.995, I think that's good enough. Good. So let's go ahead and put the bottom back on. That's what we're taking for. I think while I'm here, the PCB layout also has all of the pots identified, so there is a calibration procedure in the service manual. I'm not going to do that right now because I'm not really worried about it being super accurate, to be honest. I have other bench meters that I can use for that. But I will, while I've got it apart, just like to mark on the bottom which one's a which. So I'm going to go ahead and I'm going to do that right now. So I'm actually looking at the schematic while I'm doing this. So we've got 1, 2, 3, 4, and 6 and 7 and 8 and 9, 10, 11, 12, 13 and 14. And that leaves me with this one, which is C2. Okay, that's good. So I'm going to go ahead and put the bottom back on. And then the side. We can put the top shield on. The digital board. Push that forward as much as possible, I suppose. Resolder the power wires. Okay, let's apply some power. So we can see now we have a small offset voltage of 0.11, but this thing does actually need to warm up quite considerably before it becomes accurate. That is one of the things with this. So I think I'm going to leave it like this for now, or let it warm up, and I think that's fixed. The first thing I'm going to do is to remove the front cover, which I have already done previously. Normally this is stuck on, but as I say, I have actually taken it off already, so this should be quite a simple operation at this point. Okay, now I want to clean up all of the remaining adhesive off of here. So we'll try that with a bit of IPA. Let's see if that works. Not really. Okay, let's try and find something else. So I've found some adhesive remover here, let's give that a go. It's kind of getting it off, so that's going to be quite a long operation. So that's basically as clean as I can get it. That glue is amazing. It's a shame you can't get glue like that these days. I'm sure they've made that illegal. Anyway, so this is as clean as I can get it, which I think is okay. And what I've done, I took a scan of the back of the cover, and then I mirrored that and then printed that out and have marked all of the centres of the switch positions onto the piece of paper. And what I want to do now is to transpose those onto the front panel, so I know where the switches will be located on the front panel. So I'm going to go ahead and do that, and I shall be back when I've done it. I've used a Sharpie to transpose those positions onto the front plate, and now I'm going to insulate the plate with some tape, so I shall be back when I've done that. Kapton tape added, so I've just done the areas where the switches themselves are going to sit, just to have a double layer of insulation between the aluminium plate and the switches themselves. So the next step I need to do is to actually start making the switch array itself. I haven't really tried this. This is the first time I'm going to attempt this, so we'll see how it works out. So for the first attempt at doing this, I've selected some very flat push button surface mount switches here, and the plan is to basically build up the array like that, in using this as a template, and then I can transpose that onto the actual plate itself. So I'm going to go ahead and start joining some of these together and see how we get on. So that's the first 16 connected on one side of the switch. I'm going to go ahead and do the other 8. So that's the basic connections made. Now I need to do all the interconnections and the external connections. So I'll go ahead and start doing that now. So I've attached all of the wires necessary and made all the connections necessary for the switches, as you can see. Now I need to move this onto the aluminium backing plate. So all the connections have been made. I just need to tidy these up a little bit. I put some heat shrink sleeving over them. So here's the panel mounted. The buttons have a nice clicky feel, seem to work well. I have trimmed around the outer bezel because I've had to mount this with some tape and it sticks forward a little bit further. I don't think it would fit within the confines of the original case, so I just trimmed around it a little so it actually slots into the case, and hopefully it's going to fit. I haven't tried it yet and I will try it now. And here's the unit all reassembled back into service. All of the buttons are functioning: hold, null, recall, run. All the buttons work fine. The only thing I would say is that there is a very small gap around the edge where I had to trim. Other than that, the look is 100% original and it's working 100%. I'm actually very happy with the result, and it's a nice job. So thanks for watching this one. We'll see you next time.